Hello everyone. In this question, it is asked that if x1, x2, x3 are the roots of the cubic equation x cubed plus 3x plus 5 equal to 0, then we have to find the value of the product x1 plus 1 upon x1 times x2 plus 1 upon x2 plus x3 plus 1 upon x3. Okay, so we are given a cubic equation. Okay, let me write it with a different color. Okay, we are given a cubic equation x cubed plus 3x plus 5 equal to 0. Okay, and this has the roots x1, x2 and x3. Okay, so the sum of the roots, summation x1, which is nothing but x1 plus x2 plus x3. Okay, this is negative of coefficient of x square, which is 0 in this case, upon coefficient of x cube, which is 1. Okay, so this is equal to 0. Then we have the summation of uh, sum of product of roots taking 2 at a time, that is x1 x2 plus x2 x3 plus x1 x3. This is equal to the coefficient of x, that is 3, upon the coefficient of x cube, which is 1. So this is equal to 3. And lastly, we have the product of all the roots, which is x1 x2 x3, and this is equal to negative of the constant term, which is 5, upon the coefficient of x cube, which is 1. Okay, so this is minus 5. So these are the three values that are known to us from this given equation. Okay, so let us try to simplify this expression now. We have x1 plus 1 upon x1 times x2 plus 1 upon x2, x3 plus 1 upon x3. Okay, on simplifying, if we take the LCM in each of these terms separately, the numerator becomes x1 square plus 1 times x2 square plus 1 times x3 square plus 1 divided upon by x1, x2, x3. Okay, so if we take the product of the first two terms, we get x1 square, x2 square plus x1 square plus x2 square plus 1 times x3 square plus 1. The whole thing is divided by x1, x2, x3. Okay, so if I multiply again, we get x1 square times x2 square times x3 square plus, on multiplying x1 square we get x with 1, we get x1 square. Similarly, on multiplying x2 square with 1 we get x2 square, and multiplying x3 square with 1 we get x3 square, and we get x1 x2 square. On multiplying x1 square x2 square with 1 we get x1 x2 square. Similarly, on multiplying x1 square with x3 square we get x1 square x3 square and x2 square x3 square, and 1 times 1 is 1. Okay, so this is the entire numerator divided upon by x1 x2 x3. Okay, so for the time being we will keep it as it is. Okay, now let us try to find the values of these and this separately. Okay, let us find these sums separately. So we have x1 plus x2 plus x3 whole square. This will be x1 square plus x2 square plus x3 square plus 2 times x1 x2 plus x2 x3 plus x1 x3, right? So this value is 0, x1 plus x2 plus x3, this is 0. Okay, so this becomes 0, 0 square is 0, and we have to find this value x1 square plus x2 square plus x3 square, which is in the numerator here. Okay, so this is x1 square plus x2 square plus x3 square plus this value becomes 2 times, I think this is given, this is equal to 3. So from here we get x1 square plus x2 square plus x3 square. This 2 times 3 is plus 6, right? If it goes to the other side, it will become minus 6. Okay, so we got one sum. Now let us find this other sum. Now x1 x2 plus x2 x3 plus x1 x3 whole square. This will be equal to x1 square x2 square plus x2 square x3 square plus x1 square x3 square plus 2 times this product of this and this. Okay, so this becomes x1 x2 square x3. Similarly, product of these two will be x1 times x2 times x3 square, and the product of this first and the last term will be x1 square times x2 times x3. Okay, now this LHS x1 x2 plus x2 x3, this is equal to 3, right? We used it here, so this is 3, so this becomes 3 square. 3 square is x1 square x2 square plus x2 square x3 square plus x1 square x3 square plus 2 times. If I take x1 x2 x3 common from here, we are left with x2 plus x3 plus x1, right? So this becomes 9 equal to x1 square plus x1 square x2 square plus x2 square x3 square plus x1 square x3 square plus 2 times x1 x2 x3. This is 5 minus 5, right? So this is minus 5, so this becomes minus 5 times this x1 plus x2 plus x3. I think this is 0, right? Yes, this is 0, so this last term will become 0. So therefore we now get x1 square x2 square plus x2 square x3 square plus x1 square x3 square. This is equal to 9, right? So we got this value here. This is one value, and this is the other value. Okay, so if we use these two values in this equation, which was the required expression, the product, right? If we use these values, we can get the final answer. Okay, so x1 plus 1 upon x1 times x2 plus 1 upon x2 times x3 plus 1 upon x3. This now becomes, the first term is x1 x2 x3 whole square plus, this was the first term, right? This is x1 x2 x3 whole square, then x1 square plus x2 square plus x3 square. This is equal to minus 6, so we can substitute minus 6 here, plus the other term x1 square x2 square plus x1 square x3 square plus x2 square x3 square. This is equal to 9. Okay, 9 plus 1, and in the denominator x1 x2 x3, right? So x1 x2 x3 was equal to minus 5, so this is minus 5. Now this is again minus 5 whole square, right? So this becomes minus 5 whole square, and this is 9 plus 1 is 10, minus 6 is plus 4 upon minus 5. So this becomes 25 plus 4 is 29. So this becomes equal to minus 29 upon 5. Okay, so this is the final required answer of the given expression or given product. Okay, this is the final answer. Okay, so this was a bit lengthy in terms of getting these two products. Okay, I had to use this a plus b plus c whole square expansion 2 times. Okay, in order to get this sum of squares. Okay, and after getting that, you have to just use these values in this expression. Okay, so this is it. Okay, thank you.